Hello everyone, welcome to video lecture series on circuit analysis. In this session, I'm going to show you how we can use multisim software for the last consecutive sessions what we have discussed for the application of Ohm's law versus current law and Kirchhoff's voltage law. Okay, as you can see here, it is the main menu bar, and this one is the standard toolbar, and this one is the component toolbar, and you can consider this one is the design toolbar, and where this is the working area toolbar, and this one is the active project display. The name of the active project will be displayed on this bar. And so you can consider here there is, if you click here, this is a component, so we can have this dialog box will be displayed. So here is sources, we have different sources, and we have the signal voltage sources and the signal current sources and the control voltages, control current sources, okay, control function blocks, and digital sources and their families, okay. And we can see here also the basic components. We have the basic virtual, rated, a switch, okay, transformer, relays, sockets, schematic symbols, resistors, capacitors, inductors. So, and their families of the components will be displayed in this component bar. And this one is how we can use different families of diodes, okay, different families of diodes, and this one is the different uh, families of transistors. You can see BJT comparator, BJT PNP, BJT NPN, and we have a different IGBT for the MOSFET, FET, and channel, P channel. Okay, we have different components, and you can use this software for different application. Okay, you can see this is the button. We can make the simulation to be running, and this is the measuring, the measuring buttons. Using this, we can measure the voltage. Okay, we can measure the voltage, or using using this, we can measure the current. Using this, we can measure the uh, voltage differential. Okay, that means we can measure the voltage at two different points. Okay, at two different points, and using this button, we can measure voltage and current at the same time. Okay, and using this, we can measure the power. We can measure the power. Okay, so this is how we can measure the different values of the circuit parameters, okay. And you can see at the right side, okay, there is a multimeter here. So using this multimeter, we can measure the voltage as well as the current, okay, the voltage as well as the current. And uh, this, if you make it double click, okay. So if you want to measure the voltage, and the voltage is DC, so we can make this. If the voltage is AC, so we can select this sinusoidal button. And if you want to measure the current, okay, you can select ampere. And if the current to be measured is DC current, so you can use this constant DC value. Or if it is AC, so you can use this sinusoidal button, okay. And if you want to measure resistance, you can select ohm, okay. So using this, we can measure the current, voltage, and resistance, okay. And the other one is you can consider, for example, there is a function generator, okay, function generator. So using this, if you make it click here, double click, so it will be displayed. So there is, if you want to sinusoidal waveform, so you can use this one. If you want to use triangular waveform, you can use this one, and if you want to square wave, you can use this one, and you can make the frequencies, okay. And the other one is you can use wattmeter here to measure the power. That means the wattmeter will measure the voltage and its current internally and multiply that voltage and current and will display the power, so that if you make it, the power will be displayed here as this, and the power factor, if it is inductive load or capacitive load or resistive load, so the power factor will be displayed, okay. So using this, we can measure the power, we can measure the power. And the other one is very important, which is oscilloscope. So we can use two-channel oscilloscope, okay, two-channel oscilloscope, or you can use also four-channel oscilloscope, okay, if you are measuring AC signals, okay. So that's very important software, so you can use it. So let's see how we can measure the voltage and current, just to show the application of Ohm's law, what we have seen in the last consecutive sessions: series circuit, parallel circuit, series parallel circuits, delta Y transformation, Y delta transformation. So we can simply measure the values using this multimeter, okay. No, so now let's take a voltage source. Let's take a DC voltage source, okay. So let's say this is so you can see here, and let's take the ground. You can consider here we have the ground, okay. So if there is no ground for the circuit, so the multimeter or the circuit simulation result will be wrong result. So you can make it this, you can change this voltage, you can make it double click, and for example, let it be, this is 24 volt, okay, 24 volt. So we have the ground, and let's, from the basic components, let's take resistors. Let's take resistors, okay. So let's say this is 25 ohm, 25 ohm, okay. So let's put here, and there's another resistor which is uh, 50 ohm, okay, 50 ohm. So I can make it this, and to make it vertical, you can press Ctrl plus R, so that it will be changed. So let's finish. Let's have, this is enough for testing purpose. Okay, let's connect the devices. Just drag it and connect simply, and you can consider here. So this one, okay. Now let's connect the ground. Now we are going to, we have, this is 25 and this one is 50 ohm, okay, 50 ohm. So we are going to measure the equivalent resistance, the current pass through the circuit, and the voltage drop on R1, the voltage drop on R2, okay, R2, okay. So let's take a multimeter here. Let's take a multimeter here. You can see, since the circuit is series circuit, so the current will be constant. So I can make it an ammeter here, okay, an ammeter. So now let's delete this one because it should be connected in series. So let's double click and let's select, and the measured one is DC, so this should be connected. And another multimeter which is used to measure the voltage on R1 and R2, okay. So the voltmeter is should be connected in parallel with the device. We need to measure the voltage, okay. So as you can see here, I have connected one multimeter for resistor R1, and voltage should be measured. So, and it is DC value. It's DC value, and another multimeter I can select. So you can see here, I need to connect this and this one, okay. So we have this voltage. So this is multimeter 3, this one is multimeter 2, and this one is multimeter 1. So multimeter 1 should measure the current pass through the R1 and R2. So now let's make it run the simulation. Run the simulation. Okay. So you can see here is 8 volt. That means the voltage drop on R1 is 8 volt, and the voltage drop on R2 is that is 60 volt. 60 volt. So as you can see here, the if you remember voltage divider rule, that means the highest resistor will take or will share the highest voltage from the source voltage, yeah, and the minimum resistor will take or share the minimum voltage from the source voltage. So you can see 25, it is the minimum resistor from the series connected resistors. So you can see 8 volt will be dropped, and 60 volt will be dropped on R2. So if you sum it, okay, or that means if you take this, the summation of 8 volt and 60 volt, so it should give 24 volt. And a series current will be flow through the circuit because all the components are connected in series. So you can see here 0.32 ampere will be the current measured, the current measured. Okay, so that's how we can measure. So let's draw another circuit. Let's draw another circuit. That means so let's have one circuit, which is another circuit. Let's go to source, DC source. Okay, so let's have, this is again we'll have the ground. Okay, the ground, you can see. So let's, this one is the same voltage, which is 24 volt. Okay, I change it to 24 volt, and let's go to the component, basic components, and take resistor, which is this one, and the value is 20 ohm, 20 ohm. Okay, 20 ohm, and the other one is 10 ohm, 10 ohm. Okay, 10 ohm. So let's make it, this is vertical, this one. Okay, and the other one is 40 ohm. This is the example what we have did, we have done in the last 13th or 14th sessions. Okay, so this is 40 ohm, 40 ohm. So let's have, this is 40 ohm, and we have R3, R4, which is 60 ohm, 60 ohm. Okay, 60 ohm, 60 ohm. That means let me make it vertical. Okay, and the other one is R5, which is 50 ohm, 50 ohm, 50 ohm. And let's make it this one also vertical, just control plus right R. Okay, and the other one is R6, R6, which is 20 ohm, 20 ohm. Okay, 20 ohm. So let's close this button, or you can make it escape. So let's connect. Let's connect this one. So let's connect. And so you can see this one. Let's make sure this one is okay. So, and this is therefore. So this is the circuit. This is the circuit. So you can see here the circuit is neither connected in series nor in delta. Okay. Of course, the resistors R1 and R4 are connected in seems in parallel. It seems in parallel, but they are not connected in parallel because, as you can see, this terminal and this terminal of R1 and R2 are connected at the same point. This is the same point, but you can see here the other terminals of R4 and R1 are not connected at the same terminal, okay, at the same point. So R1 and R4 are not in parallel, are not in. The only thread connection is R6 and R5. So we are asked to measure total current I naught. Total current I naught. Okay, I naught. Let's take this. So yes, that means we are asked to determine this total current. This total current. So we are going to connect a multimeter. We are going to connect multimeter on the circuit. That means let's have this in series. Okay, so this is, so let's make it run the simulation. Let's make it run the simulation. Okay, so you can see here you can see here, so I can make it double click. Okay, sorry. So that's around 1 amperes. Okay, we have tried to calculate the total current in the previous video lecture. Okay, it is almost, we have got 1 ampere, and this is also, it is approach to 1 ampere. So our calculation was correct. Okay, so this is how you can measure the total current. How you can measure the total current. Now let's calculate or measure also the power. Okay, let's make it stop the running of the simulation, and let's take wattmeter. Okay, so we can measure the values of the power which is consumed by, for example, by R4. That means we can measure the voltage, the voltmeter. Wattmeter is consisting of basically consisting of multimeter and on a meter. Okay, so let's connect this also. Then this is the ammeter. Okay, so let's this one. Then as you can see here, the ammeter is connected in series and the voltmeter is connected in parallel. So internally the wattmeter will measure the voltage and current, so that it will take the product of voltage and current. So let's make it double click here. So the power will be displayed here and the power factor will be displayed at this point. So let's make it, let's run the simulation. Okay, let's run the simulation. So as you can see here, the power consumption by R4 is, that is 2.856 watt, and the power factor is 1. Okay, the power factor is 1 because it is pure resistive circuit. It is a pure resistive circuit, so there is no inductance, there is no inductor, there is no capacitor. So definitely the power factor is 1, because the phase angle difference between the voltage and the current will be 0. That means the power factor angle is 0. So the power factor, I mean cosine of 0 will be 0. So that's a correct result. And you can use the potential difference between 2 points. You can measure, for example, from this point to this point. You can measure from this point to this point, or from this point to this point. For example, you can take differential voltage. That means from this point, then you can take this. So it's around, if you see, it's around 20.9 voltage. From this point to this point, the voltage will be 20.9 volt. That means the sum of the voltage drop on this and on this resistor R5. That means the voltage drop on R4 and R5 will be 20.9 volt. 20.9 volt. And you can measure also the current which is passing through what? The R6. R6. Okay? R6. You can see it is around 0.156. It's around 0.156 ampere will be flow through R6. And you can measure also the voltage between R3 or the voltage drop on R3. That means, for example, you can take this one and this one. So that is minus 2.49. It's minus 2.49 volt or voltage is dropped on R3 Okay, so using this approach, we can measure any circuit element variables. Okay, any circuit element variables or the voltage across or the current through any element we can measure. So as you can see, it is very simple software, so anyone can use it, and you can make it his own or her own electronic circuit or basic circuit analysis can be performed by using this multisim software. It is very simple, it is very user friendly, and anyone in the field of electrical engineering or any students, okay, can use this software. That's okay. So that's how we can measure voltage, current, okay, voltage, current, and power using the multisim software. Okay. One thing we left with is how we can measure the resistance of the circuit. For example, we can make it. Let's stop this one. Okay. So let's take this one. Let's delete this one. And let's delete this one. Okay. So let's connect. So to measure the resistance or the total resistance from this point, okay, let's remove the source voltage. Okay, the source voltage, and you need to remove the ground to measure the resistance. So we are going to take the multimeter. Okay, multimeter. So you can rotate. That means so let's take simply. That is, this is the total resistance. So you can see here, I need to measure the total resistance from this point to this point. So I need to, or let's make it run the simulation so that you'll have this. That is this 24.062. This is, which is exactly equals to the calculated one, which is we have done in the previous video lecture. Okay, so that's all for this session. Please follow, share, subscribe, and like the video lecture so that it will be accessible for other users. Thank you very much.